All right, so let's go over the answers to this final example. We have the graph of g of x here, and the first question is what is g of negative 9? So we'll look on the function. As the function is approaching an x value of negative 9, the y value is negative 9, so there's number one. Number two, g of negative 4, so we'll look on the graph. I have two options. There is this green, and then there is this turquoise. However, the turquoise one doesn't exist. There's a hole in the graph for a y value when x is negative 4 is a y value of negative 4 also. Number three, g of 7. So we've got to go to the right. When x equals 7, we don't use this hole in the graph. Instead, we use the value where the point actually is. So g of 7 is equal to 3. Number four, g of 0 is equal to 6. It is that green point. Number five, as x approaches negative infinity, what is y trending towards? So if I start tracing this graph as we go more and more towards the left, I see the arrow on the end of it and it's trending up, and there's no indication that it's going to stop, which means this limit does not exist. More specifically, because the graph is going up without bound, we can say it does not exist and it's going towards infinity, getting bigger without bound. Problem number 6, now we're going to the right. So as we trace this one going to the right, and as it keeps going to the right, the graph keeps going up. So once again, the limit does not exist. More specifically, we're saying how it doesn't exist, getting infinitely large. So the limit is going to be towards infinity. Number 7, the limit as x approaches 4. So as we look at it from the left and we look at it from the right, they're both approaching this value of 9. Number 8, the limit as x approaches negative 4 from the left. So as I'm tracing the graph, coming at it from the left-hand side, it's going closer and closer to a y value of negative 4. So 8 is going to be negative 4. Problem number 9, the limit as x approaches negative 4 from the right. So now I'm tracing the graph coming at it from the right-hand side, and this is trending towards a y value of positive 3. So number 9 is positive 3. Number 10 brings those two together. Since from the left, it's approaching negative 4, and since from the right, the limit of the graph as x is approaching negative 4 is 3. Since these two numbers are different, that means the limit does not exist. They're not trending towards the same value. Number 11, as x approaches 0, the limit of g of x is 6. That is right here, which is the same answer we had for 4. They're different questions. What's significant about this is that since the limit is 6 and since the value of the function is 6, that is our definition for continuous. So we could say the function g is continuous at x equals 6. All right, so number 12, as x approaches negative 7 from the left. So I'm looking at the graph as these x values are approaching negative 7 from the left. It is trending up infinitely. So number 12a is infinite. Whereas if we were to trace this graph as x is approaching negative 7 from the right, so our x values are getting closer and closer to negative 7, but those y values are trending down. So 12b is going to be a negative infinity. It goes down forever. But since those two graphs are not converging, one is going up, one is going down, that means our limit does not exist. 12b, g of negative 7. So if I look on the graph, when x equals negative 7, the value of the function is this guy right here, over equal to 2. And now as I look at x approaching negative 7, since the limit from the left and the right does not exist, I already know it's not continuous. Even more so, this value of the function isn't equal to the limit from either side. So definitely not continuous. Number 13, the limit as x approaches 7 from both sides. So there's no positive or negative. So as I'm trending towards an x value of 7 from the left, I'm approaching that value. And as we're getting closer and closer to an x value of 7 coming at it from the right side, I'm approaching that same value. The fact that there's a hole in the graph isn't significant to this question because they're both intending to get to the y value of negative 8. Our limit is negative 8. Now, what is significant about this value in the big picture is that since the limit equals negative 8 and the value of the function, which we did up here in question number 3, is equal to 3. Since those do not equal to each other, that's how we know by the definition that the limit is not continuous.